Let's learn about exponents and some exponent laws. So what is an exponent exactly? An exponent looks something like this. So let's say you have 3 and you're raising it to the second power. So the number hovering above our 3 right over here is something called an exponent. And basically, what the exponent tells you to do is it tells you to keep. So this thing tells you that you're taking this 3 right over here and you're multiplying it by itself 2 times. You're multiplying this 3 2 times by itself. If I had 4 to the third power, what I'm essentially doing is I'm taking this number right over here, the number in front of the exponent, and the number in front of the exponent is actually called the base. So what you're doing is you're taking the base of this exponent and you're multiplying it by itself. Well, in this case, 3 times. So 4 times 4 times 4. So exponentiation is basically just repeated multiplication. So the first rule, exponent law, I'm going to be talking to you about is something called the product rule. And this states that, let's say that you have a to the n power. So you have some number to the n power, and you multiply this by a to the m power. And this is just going to be equal to a to the n plus m power. So for example, let's say that I have 3 to the second power, and I multiply this by 3 to the third power. What is this going to be equal to? Well, what you'll notice, first of all, is that the base of both of these numbers right over here are the same. Right? Both of these numbers have the same base. And what this is going to equal to is you're going to keep the base, so that for your answer right over here, what it's going to be equal to, you're going to keep the base and you're going to add up the exponents. So this is going to be equal to 3 to the 2 plus 3 power, which is equal to 3 to the 5th. I'll do another example. Let's say that we have 4 to the third power, and we multiply this by 4 to the second power. Well, this is just going to be equal to 4 to the 3 plus 2 power. So keep the same base, add up your exponents, and this is just going to be equal to 4 to the 5th power. And the reason why this works is, well, let's actually take this example. We know that 4 to the third power, what is 4 to the third power? Well, you're taking the base of your exponent, so this 4 right over here, and you're multiplying it by itself 3 times. So this is just going to equal to 4 times 4 times 4. And 4 to the second, well, you're taking your base of the exponent, which is the 4, and you're multiplying it by itself 2 times. So this is just going to be equal to 4 times 4. And you're multiplying 4 to the third, which is this, times 4 to the second, which is this. And what you'll notice is that when we multiply all of these 4s together, well, how many 4s are there? There are 1, 2, 3, 4, 5 4s. So this is just going to be equal to 4 to the 5th power, because all of those are 4, and there are 5 4s in total, and you're multiplying all of them together. So it's just going to equal to 4 to the 5th power. So that's kind of why the product rule works. You can break these down into these individual parts, and ultimately, when you multiply out together, it's just going to be equal to if you just added the exponents together. So keep the same base, add the exponents. Now let's talk about something called the quotient rule. And this is very similar to the product rule. The quotient rule states that if you have a to the n power and you divide it by a to the m power, this is just going to be equal to a to the n minus m power. So when you're dividing exponents with the same base, what you do is you keep the base and you subtract the exponents. So this is kind of like the product rule, except instead of adding the exponents, you subtract the exponents. So let's say if we have 4 to the third power and we divide it by 4 to the second power. And we could also rewrite this. We can also rewrite it as this. 4 to the third power divided by 4 to the second power. You're still going to get the same answer. So let's say 4 to the third divided by 4 to the second power. And this is just going to be equal to, well, you keep the same base, so it's still going to be a 4, and you subtract the exponents. So this is just going to be equal to the 4. This is just going to be equal to 4 to the 3 minus 2 power, which is equal to 4 to the 1 power. And anything to the 1 power, so this is actually another exponent rule. Any number to the first power equals to that number itself. So 4 to the 1 power is going to be equal to 4. If I have 2 to the 1 power, that's just going to be equal to 2. 3 to the 1 power, that's going to be equal to 3. So any number to the first power is equal to the number itself. Let's do one more quotient rule example. So let's say if I have 5 to the 5th power, and I divide it by 5 to the 4th power, or let's actually say we divide it by 5 to the 2nd power. Well, what is this going to be equal to? Well, you keep the base of your exponent and you subtract the powers. So this is just going to be equal to 5 to the 5 minus 2 power, 5 minus 2, and this is just going to be equal to 5 to the third power. And why does the quotient rule work? Well, let's actually take this example right over here. 5 to the 5th power divided by 5 to the 2nd power. You can write 5 to the 5th power as 5 times 5 times 5 times 5. So let me just do this in this color. So you'll see that 5 to the 5th power is equal to this part. And this is going to be divided by 5 to the 2nd power. And we know that 5 to the 2nd power, well, you're taking 5 and you're multiplying it 2 times by itself. This is just going to be equal to 5 times 5. And what you'll notice is that we have a 5 on the top and we have a 5 on the bottom. So what we can actually do is we can cancel them out. It's just like if you have a fraction, like let's say 4 over 2, you're able to cancel the 4 out with the 2 so that you're left with a 2. Because 4, we know that 4 is equal to 2 times 2, and it is going to be divided by 2. And you notice that we have a 2 in the numerator and a 2 in the denominator, and we can cancel these common terms out. So as long as it's a common term, so as long as the numerator part is the same as the denominator part, and as long as this is being multiplied by some other number, well, you're able to cancel the part of the numerator with the denominator out. If you had something like 2 plus 1 divided by 2, you can't cancel it out because it's not multiplication. However, in this example, right, it's 2 times 2. This is multiplication, meaning that you have a common 2 in the numerator, common 2 in the denominator, right? This is the same thing as 2 times 1. So both multiplication, both common terms, you're able to cancel it out. And this is the case here. We both have common terms in the numerator and denominator, and they're being multiplied by each other. This is being multiplied here, this is being multiplied here. You're able to cancel them out. So let me just cancel them out real quick. And you have another 5 in the numerator and another 5 in the denominator. You can cancel them out. And guess what? You are just left with 3 5s, or 5 to the 3rd power. So this is why the quotient rule works, because you're able to cancel out the stuff in the numerator with the denominator, and the result you're going to be left with, this is just going to be equivalent to subtracting the exponents from the numerator. Now let's talk about powers of a product. So powers of the product. And don't confuse this with the product rule. So that's really important because let me actually just write this out. So let's say that you have a to the n power, and you multiply this by b to the n power. So you notice how in this case the bases of our exponents are different, and it doesn't have to be the same, but our exponents in this case are the same. So the bases in this case are different, can be different, and our exponents are the same. And this is just going to be equal to well, you keep the exponent and you multiply the bases together. So if you have 3 to the 4th power times 5 to the 4th power, what you do is you keep the exponent and you multiply the bases together. So 3 times 5 to the 4th power, which is just 15 to the 4th power. If we have 3 to the 3rd power times 10 to the 3rd power, keep the exponent. So we're still going to, whatever we have here is still going to be raised to the 3rd power, and we multiply the 3 and the 10 together. So the bases together. So 3 times 10. And this is just going to be equal to 30 to the 3rd power. And why does this formula work? Well, this is because, well, let's actually take this example right over here. And when we use this formula, we got 3 times 10 to the 3rd power. Now let's expand this. So when you're doing exponents, what we do is we take the base. So in this case, the base of our exponent is 3 times 10. And what we do is we multiply the base, in this case, 3 times. You take whatever is inside the exponent, I guess, and then you just multiply it by itself, well, 3 times. So what's inside the parentheses? Well, this 3 and the 10. So 3 times 10, and we're going to multiply it by itself 3 times. So this is just going to be 3 times 10 times 3 times 10 times 3 times 10. So you just do whatever inside the parentheses, and because it's the 3rd power, you multiply it out 3 times. And what you'll notice is that, well, let's actually group the threes together and group the 10s together. What I mean by that is, well, multiplication is commutative, meaning that 7, let's say if we have 7 times 5, this is just going to be equal to 5 times 7. And this is because multiplication is commutative, meaning that the order in which you multiply stuff doesn't really matter. For example, you can have any number, 3 times 4. That's going to be equal to 4 times 3. So in this case, let's actually group all the 3's together. So this is going to translate to, well, if we group all the 3's to one spot, this is going to be 3 times 3 times 3. And if we group the 10's to one spot, let's group the 10's actually in different colors. So see, if we group the 10's to one area, this is just going to be multiplied by 10 times 10 times 10. 10 times 10 times 10. And we will notice is that we have 3 3's, or in this case, we can rewrite this as 3 to the 3rd power because there's 3 3's, and we can rewrite this as 10 to the 3rd power. And you'll notice our original expression, our original thing was 3 to the 3rd power times 10 to the 3rd power, and we managed to get back at that spot. So the reason why this power of a product rule works is because multiplication is commutative and doesn't matter what order you multiply in, so you're able to manipulate this expression, so that you can, it's going to be equivalent to your original expression. Now let's actually talk about powers of a quotient. So in this case, let's say that we have a to the n power, and we divide it by b to the n power. This is just going to be equal to a divided by b to the n power. So this is basically the same formula as the powers of a product, except that it turned from multiplying the bases together to dividing the bases together. For example, if we have 4 to the second power divided by 2 to the second power, well, what is this going to be equal to? Well, what you do is you keep the exponent, so you keep the same exponent, and you divide the bases. So 4 divided by 2 to the second power, which is equal to 2 to the second power. So you have 9 to the third power divided by 3 to the third power. Well, you keep the exponent and divide the bases together. 9 over 3, that's going to be equal to 3 to the third power. And why does this rule work? Well, let's say that we have, let's use the previous example we did. 4 to the second power, and we divide it by 2 to the second power. I'm going to write it in this fraction form. And what is this going to be equal to? Well, the formula says that this is going to be equal to 4 over 2 to the second power. Right? That's what we got for our answer. And what is 4 over 2 to the second power equal to? Well, this is just going to be equal to, well, whatever's inside, whatever is your base, and you multiply it 2 times by itself. So this is going to be equal to 4 over 2 times 4 over 2. So 4 times 4 is 4 to the second power, and 2 times 2 is 2 to the second power. So this is the reason why it works, is because, well, when you're raising fractions to a certain power, you multiply the numerator by itself some number of times, and denominator. Let's learn about something you might have expected, to never exist, and that's the idea of negative exponents. So let's say if we have 4 to the negative 1 power, what is this going to be equal to? Well, whenever you're doing negative exponents, let's say that I have a to the negative m power. So a to some negative integer value. Well, this is going to be equal to 1 over a to the m power. So in this case, if we apply this formula, our a value is equal to 4, our negative m value is equal to negative 1. So this is just going to be equal to 1 over 4 to the exponent. So let's do another example. This is a pretty confusing concept to understand at first, but let's do a couple more examples and maybe you'll get the hang of it. Let's say we have 5 to the negative 2 power. What is this going to be equal to? What we're going to do is this is always going to be 1 over, and you keep the 5, and you take the exponent and you turn it positive. So 1 over 5 to the second power. Let's do it again. Let's do 6 to the negative 4 power. What is this going to be equal to? This is going to be 1 over, you keep the base of your exponent, and you turn the exponent positive. 1 over 6 to the 4th power. 7 to the negative 3 power. Well, what is this going to be equal to? Well, this is going to be equal to 1 over, keep the base, turn the exponent positive. 1 over 7 to the 3rd power. Now let's actually talk about raising numbers to the 0th power. And it turns out that if you take any number and you raise it to the 0th power, it's going to be equal to 1. For example, 1 to the 0th power is equal to 1. 2 to the 0th power is equal to 1. But why is that? Why does this work? How do you take a number to the 0th power? How can you multiply something 0 times by itself? Well, let's take a look. Let's say we're trying to find out what 2 to the 0th power is. Well, we can rewrite this as 2 to the 1 minus 1 power. And there's actually a couple ways to prove that a to any number to the 0th power is equal to 1, but I'll just use this method. So we can rewrite 2 to the 0th power as 2 to the 1 minus 1 power. See, because 1 minus 1 is equal to 0. So these two things are equal to each other. And from the quotient rule, remember that when we have a to the n minus m power, so when you have a to one exponent minus another exponent, well, this is going to be equal to a to the n power divided by a to the m power. In this case, right, we have 2 to the 1 minus 1 power. So this is going to be equal to 2 to the first power, 2 to the first exponent, divided by 2 to the other exponent, 2 to the other exponent in this case. So 2 to the first power divided by 2 to the first power. And anything divided by itself is equal to 1. This is going to be equal to 1. If we have 2 divided by 2, that's equal to 1. So that's kind of why, this is why any number raised to the 0th power is equal to 1. Because you can rewrite it in this form. You can use the quotient rule, and in fact, you can actually also use the product rule and apply negative exponents to that, but I'm not going to. Actually, I might show you that. But in this case, we use the quotient rule, and we were able to simplify this so that it equals 1. And actually, let me show you the other method, because that kind of links up everything together. So in this case, we are left with 2 to the 1 minus 1 power. Now, let's use the product rule. And remember, this states that if you have a to the n power and you multiply this by a to the n power, you just add up the exponents. So in this case, we can rewrite 2 to the 1 minus 1 as, well, 2 to the 1 plus negative 1. 2 to the 1 plus negative 1. This is still the same thing. And now we can use the product rule. We can say that this is equal to 2 to the 1 power times 2 to the negative 1 power. 2 to the first exponent times 2 to the other exponent. Well, you just add the exponents up together, which is what we had right over here. You add up the exponents, the base of our exponents are the same, and you're able to add up these exponents so that it equals 2 to the 0th power. 2 to the 1 minus 1 is equal to 2 to the 0th power. Now what you're going to do is you're going to use properties of negative exponents. And negative exponent, well, a to the negative m power is equal to 1 over a to the m power. So essentially what you do is you can rewrite this part, so we can still keep 2 to the first power, and rewrite 2 to the negative 1 power as 1 over, you keep the base, and you turn the exponent positive. So 1 over 2 to the first power, or just 1 over 2. And 2 times 1 over 2 is equal to 1. So you see how we can use the product rule to prove that any number to the 0th power is equal to 1, or you can use the quotient rule to prove that any number to the 0th power is equal to 1. So that's pretty cool. Let's learn how to simplify some expressions. So say that I have, let's say 4, let's say that I have 4a to the second power, and I divide it by 2a. What is this expression simplify to? Well, the trick here is If you're new to these types of problems, you might be confused. There's letters and there's numbers, and you don't know how to simplify this. So what I like to do is I like to break this down into two different fractions. So the first fraction we can write as 4 over 2. And this is going to be multiplied by a squared over a. And you kind of see what I did there. I separated the letter part of the fraction, so this part of the fraction, from the other part of the fraction. I separated the letter part from the number part of the fraction. And you're able to do this because, well, properties of fractions. 4 over 2 times a squared divided by a. Well, if you multiply 4 times a squared together, you get 4a squared. And if you multiply 2 and a together, it multiplies out to be 2a. So from properties of fractions, if you ever see letters, numbers inside of the expression, you're able to separate the letters from the numbers. So now this is actually pretty simple. 4 over 2 is equal to 2. And this is going to be multiplied by, well, a squared divided by a. Well, from exponent properties, you might have remembered the quotient rule, which tells us that if you have a to the m power and you divide this by a to the n power, well, this is going to be equal to this is going to be equal to a to the m minus n power. So basically, for example, if you have 3 to the 4th power times 3 to the 3rd power, what you do is you keep the base of the exponent, which is the 3. So the base of the exponent is the thing that's in front of the exponent. You keep the same base as your answer, and you subtract the exponents. So 4 minus 3 is equal to 1. So that's just a simple example. And that's what we're going to do right here. What we do, a to the 2nd power divided by a, in this case, a to the 1st power. Well, what you do is you keep the base of the exponent, which is a, and you subtract the exponents. 2 minus 1 is equal to 1. So 2 times a to the 1st power, which is just 2a. And there's our answer. Now let's say that I'm going to make this a little bit more complicated. So let's say that we have x squared, actually, let's say 9x squared, y times y squared divided by 3x to the 5th, y to the 5th. What is this going to be? What does this expression simplify out to? Well, once again, I'm just going to use the simple fact that I can separate all of these into 3 fractions. I can separate this into 3 fractions. I can separate this into a fraction that contains only the numbers. So I can separate this into 9 divided by 3. Those are our numbers. Multiplied by, I can separate this fraction into only the x's. So x squared divided by x to the 5th power. And I can separate this into a 3rd fraction. So y to the 2nd power divided by y to the 5th power. So I separated numbers from the x's from the y's. And now we can start simplifying this. 9 over 3, that's just going to be 3. X to the 2nd power divided by x to the 5th power. Well, we're going to use the quotient rule once again. So let me write this out. X to the 2nd power divided by x to the 5th power. What you do is you keep the base of the exponent and you subtract the exponents. So 2 minus 5. So x to the 2nd power divided by x to the 5th power, you keep the base. In this case, our base is x, so we keep the x and we subtract the exponents. So 2 minus 5, that's just going to be equal to x to the negative 3 power. And same thing for the y's. Y to the 2nd power divided by y to the 5th power. What you do, so right over here, what you do is keep the base of the exponent. In this case, you keep the y, and you subtract the exponents. So 2 minus 5, that's negative 3 once again. And there we go. Our answer is 3 times x to the negative 3 power times y to the negative 3 power. And you can also rewrite this in another way using using the properties of negative exponents. So let's say if I have x to the -1 power, this is going to be equal to x to the 1 over x to the 1 power. Let's say I have x to the -2 power. That's going to be equal to 1 over x to the 2nd power. So that's kind of how negative exponents work. You put a 1 over that, the whole thing right here, except the exponent is positive. So in this case, so actually, let me just erase this real quick. So in this case, what I can do is I can rewrite this as 3 times, actually, so 3 times, well, x to the -3rd power is the same thing as 1 over x to the 3rd power. So you put a 1 over, and then you turn this exponent positive instead of negative. So it's going to be 1 over x to the 3rd power. So this is 1 over x to the 3rd power times, well, y to the 3rd power, and y to the -3rd power can be rewritten as 1 over y to the 3rd power. So times 1 over y to the 3rd power. So this whole expression can be rewritten as 3 times, actually 3 divided by x to the 3rd power times y to the 3rd power. And there we go. So all I did there was just multiply out the fractions together. I multiplied the numerator all at once. So 3 times 1 is just 3. And I multiplied the denominator together. 3x to the 3rd times y to the 3rd is just those two things combined. And there we go. Now let's see if we can simplify this expression. So what do we do here? Well, the first thing that might pop out to you is that we have basically two exponents. We have powers raised to another power. And the way you deal with this is, let's say, let me just give you a random example. So let's say if we have 8 to the 2nd power raised to the 3rd power. And we're trying to find out what this is equal to. Well, what you would do is you would just multiply the exponents. So this is going to be the same thing as 8 to the 6th power. See how I just multiplied the exponents together? So in this case, what we can do, so to deal with x to the 2nd power, y to the 3rd power, and all of this is raised to the 2nd power, what you would do is you would just multiply both of these exponents right over here by 2. So the numerator is going to be equal to x to the 4th power times y to the 6th power. So you kind of see I just multiplied this 2 by this 2 right over here, which gives me x to the 4th power, and I multiplied this 2 by this 3 over here, which gives me x to the 6th power. Y to the 6th power. And this is going to be divided by, well, let's do the same thing in the denominator. This is the same thing as x to the 1st power, so let me just multiply the outer exponent by the inner exponent. 4 times 1 is x to the 4th power, and this 4 times this 3 is going to be equal to y to the 12th power. So that's kind of the first step. Just distribute the powers, just distribute the power, and kind of multiply it by all the terms, all the exponents inside the parentheses, and boom. Now what we want to do, finally what we do is we use the quotient rule once again. So what you do right now, if it helps, you can separate it into 2 fractions, but you actually don't really have to do that, like once you get used to it. And what you'll notice is that x to the 4th power, so actually x to the 4th power divided by x to the 4th power, so this part right over here, well, anything divided by itself is equal to 1, so this kind of cancels out. This kind of cancels out. and y to the 6th power divided by y to the 12th power, well, what you do is you keep the same base, and you subtract the exponents. So 6 minus 12 is equal to negative 6, and y to the negative 6 can be represented as 1 over y to the 6th power. So you write 1 over this whole exponent right over here, except the exponent turns positive, kind of. So yeah, that's basically how you simplify this expression. Now let's see if we can simplify this expression. And these are just parentheses, so I kind of make things clearer. So this is x to the 2nd power times x to the 3rd power divided by x to the 4th power times y to the 2nd power times y to the 3rd power all over xy. And the first thing I want to do, I want to clear up the numerator first. So how can I do this? Well, whenever you're multiplying two exponents with the same base, so let's say if we have x to the n power times x to the m power, and you'll notice that they have the same base, they're being multiplied together, well, all you have to do is add up the exponents. Keep the base, add the exponents. So in this case, if I have, like, let's say 3 to the 3rd power times 3 to the 4th power, you notice that they have the same base. So what you do is you just add up the exponents. So this is going to be equal to 3 to the 3 plus 4 power, which is equal to 3 to the 7th power. So you just add up the exponents and you keep the same base. So using this product rule, we're able to simplify the numerator. And we can say that x to the 2nd power times x to the 3rd power, well, what you do is you keep the same base and you add up the exponents. So this is going to, this right over here, let me just rewrite it, x to the 2nd power times x to the 3rd power divided by x to the 4th power. X to the 2nd power times x to the 3rd power is going to be equal to x to the 5th power. Keep the same base, you add up the exponents. 2 plus 3 is equal to 5. So now let me just erase this. So now we can replace this with an x to the 5th power. And now x to the 5th power. Now we have x to the 5th power. So this whole thing right over here divided by x to the 4th power. And using the quotient rule, all we have to do is we keep the same base, so we are left with x, and we subtract the exponents. 5 minus 4 is equal to 1. So this whole thing right over here clears out to x to the 1st power. This whole thing clears out to x to the 1st power. Let me just erase all of this. So this right over here is x to the 1st power. And now we're just left with this part. We're left with this part of the numerator. Well, we're going to use the product rule again. Y to the 2nd power times y to the 3rd power. What is this going to be equal to? Well, once again, you keep the same base. So it's still going to have the base y. And you're going to add up the exponents. So 2 plus 3 is equal to 5. So this whole thing right over here is y to the 5th power. And finally, what you do is you use the quotient rule for this numerator and this denominator. X to the 1st power divided by x to the 1st power. Well, that cancels out because anything divided by itself is equal to 1 except for 0. So, yep. We can cancel this out. Cancel all of this out. And y to the 5th power divided by y, well, you can think about just a plain old y as y to the 1st power. So y to the 5th power divided by y to the 1st power, well, what is this going to be equal to? Well, what you do is you keep the base, and because you're dividing, you subtract the exponents. So 5 minus 1 is equal to 4. And there's our answer. y to the fourth power.